In this example, we're integrating sine squared of x cosine to the fourth power of x dx. As you already know that to evaluate the trigonometric integral, we usually use substitution, right? And we'll let either sine be equal u or cosine. So if we let u be equal sine of x, well then du is cosine x dx. So this means that we would want to separate one factor of cosine of x, and along with dx, it will be equal du. Well, let's see how it's going to look like. So sine squared of x, that's what u is. And by the way, that's option number 1. Then cosine to the fourth power, I write as cosine cubed of x, cosine of x dx. Now that part is du, and I am facing the problem here because remember how we have odd power of cosine or sine. We're not able to rewrite it using identities, right? So now my goal would be to rewrite cosine in terms of sine so that I can introduce u or replace it with u. But odd power is not allowing me to use any identities. They all involve second power. Okay, so we're stuck with this option. Let's try second option. With the second option, we would let u be equal cosine of x. In this case, du is negative sine x dx, or if I divide by a -1 on each side, it's going to be negative du equals sine x dx. So that would mean that cosine I will replace with u. It's going to be u to the fourth power. And to introduce du, differential du, I would need to have sine x dx. Well, I can separate one sine, one factor of sine from here, right? And this is how it's going to look like. Now, sine squared I'm going to rewrite as sine. Then I will copy down cosine to the fourth power. And then another sine from here I'm going to put at the end. Sine x dx. And now as I make notes here, cosine is u, sine x dx is negative du, but here's the problem again. I'm left with an odd power of a trig function, so it's sine to the first power, and I'm not able to write it in terms of cosine. That's what I would want to do, because cosine can be replaced with u, because all identities that relate sine of x and cosine of x involve second powers, right? So here's the problem again. Why have we experienced the same problem for both options? Well, because in this example we have only even powers. If you watched example number 1, I briefly explained that we would need to, for one of the options to work, we would need to have an odd power of sine or cosine, and here we don't have that, right? So that's why we stuck with those two options. We need to do something else. So this example illustrates if you have trigonometric integral with both functions, sine and cosine, being raised to even powers, you need another method. And that method will be the following. We're still going to be using identities, but different kind of identities. They're going to be half-angle identities. Let me remind you what they are. We saw them in the introduction video, but we have those two identities. It's sine squared of x. So sine squared of x can be replaced by 1/2 1 minus cosine of 2x. And then cosine squared of x can be replaced by 1/2 1 plus cosine 2x. So notice, like in both cases, whether it's sine squared or cosine squared, the right hand side is in terms of cosine only, right? Cosine of 2x, cosine of 2x. It means that if we take our trigonometric integral that involves functions raised to the even powers, then as we replace each using those two identities, we will end up with some kind of expression involving only cosine of 2x. And we will be able to proceed from there. So let's try. So my integral, I'm going to write the original one. It's sine squared of x cosine to the 4th power of x dx. Now, here I can right away see that sine squared of x will be replaced by this expression, right? But I don't have cosine squared of x. I have cosine to the 4th power of x. Well, it's actually not a big deal because I can always rewrite any even power as square, so cosine squared of x, and then raise to whatever it has to be to produce the original power. Well, in this case, it has to be 2nd power, right? 2 times 2 is power of 4, or square of a square is the 4th power, dx. Okay, and now I will use the identities. So sine squared of x, I'm replacing with 1/2 1 minus cosine of 2x, right? And then, so that's, so that's sine squared of x. And then cosine squared of x inside the parentheses, I'm actually going to change that to brackets. Cosine squared of x inside the brackets will be from here 1/2 times 1 plus cosine of 2x brackets, and then that outside 2nd power dx right here. Okay, and here, okay, so let me make a note. That is cosine squared of x. So to evaluate this integral, first I want to simplify this expression. I will apply this square. I need to be careful because it applies to both 1/2 and this expression, 1 plus cosine of 2x. So I have, now that 1/2 I can put in the front for now. It's going to be another factor, but I'll keep it here. So 1 minus cosine of 2x times, now that becomes 1/4, and 1 plus cosine of 2x squared dx. Now 1/4 will be put in the front with 1/2, so they're going to be multiplied. 1/8 integral 1 minus cosine of 2x times, well, and that has to be squared, so I have to write it as 1 plus cosine of 2x times 1 plus cosine of 2x times 1 plus cosine of 2x. And if I multiply that out, it's going to be 1 plus cosine of 2x, and then plus another cosine of 2x, so plus 2 cosine of 2x. And then finally, plus cosine squared of 2x dx. And now those two expressions have to be multiplied as well. Let's see what we're going to end up with. We haven't even started integrating yet. 1 times 1 is 1. Plus, okay, so it's 1 times all of that, so I just have to rewrite plus 2 cosine of 2x plus cosine squared of 2x. And then minus cosine of 2x minus 2 cosine squared and then finally minus cosine to the 3rd power of 2x. dx. Do I have any like terms? I think I do. So 2 cosine of 2x minus cosine of 2x, that can be combined. So 1 plus cosine of 2x. Now cosine squared of 2x minus 2 cosine squared of 2x. That's minus cosine squared of 2x. And then minus cosine to the third power of 2x dx. Now let's integrate. So that becomes a pretty long example, but the main portion is done. So the whole point of that example was to show you that if your trig functions are raised to the even power, both of them, or if you only have one, that one function raised to the even power, you would want to use those half angle identities. Okay, now the rest is either just basic integration or something that we already reviewed, so I'm going to go a little bit faster about the integration process itself. There are 4 pieces here, right? So 1, 2, 3, 4, and we're going to integrate them separately. Now, integral of 1 is just x. Integral of cosine of 2x is just the basic u substitution, so I'm going to write down the answer. It's going to be 1/2 sine of 2x. But those two, we're going to integrate on a side. It's going to be our scratch work. So I'm going to do part 3 here on the side. So that's integral of cosine squared of 2x dx. Now once again, notice that we have trig function raised to the even power, and there's nothing else there. So the only way to integrate it is by using those same, or that same identity for a half angle. So we're going to rewrite cosine squared of 2x. Now I will write the identity, which is cosine squared of x equals 1/2 times 1 plus cosine of 2x. But notice that this identity is defined in terms of x, and we have 2x, right? So we have to be careful. We just need to notice that if on the left hand side it's x, and on the right hand side it's twice that, 2x. So if my cosine squared has 2x, then what I replace it with will have double of that, so it's going to have 4x. So that's 1/2, I'm going to put 1/2 in the front, of 1 plus cosine of 4x dx. And now integral of that is constant. Integral of the constant is x, and then integral of cosine is sine, and I'm skipping basic u substitution here. The only thing that will give me is that coefficient 1/4 once I integrate. 1/4 sine of 4x, and you can just try it on the side if you're not sure what happened here. Just do basic u substitution. In other words, 4x equals u, and then integrate from there. 1/4 sine of 4x plus c. So that's 1/2 x plus 1/8 sine of 4x plus c. Now that was part 3. Part 4 is integral of cosine cubed of 2x dx. Now this time we have an odd power, and that's good because I know that I can separate one factor of cosine of 2x and put it with dx, right? Now so that I can introduce differential du. Well, if cosine 2x dx will be differential, it means that u has to be sine of 2x. And if you're not sure, like, why is it sine, we'll try both sine and cosine. Remember how we did? We're just trying different options. I'm just trying to save time here. So u is sine of 2x. It means that du is cosine of 2x. Oh, I'm sorry. I have 2x, so I have to do chain rule, right? So it's cosine of 2x, but then also derivative of 2x, which is 2. So it's 2 cosine of 2x dx. So that means that cosine 2x dx is, I'm dividing on both sides. I'm dividing by 2 on both sides. So it's du over 2, or 1/2. Du is cosine 2x dx. So that what happened, I separated cosine cubed into cosine squared 2x, and then times cosine of 2x dx. Now that part I know is 1/2 du, but then how do I introduce u itself? Well, cosine squared of 2x can be replaced with sine squared using just the basic identity. So that's same as 1 minus cosine squared, sine squared of 2x. Right? Using basic identity. So that means it's going to be 1 minus u squared. So here's my integral. Integral of 1 minus u squared, 1 minus u squared, and then 1/2 du. So sine of 2x is u. Okay, so 1/2 goes in the front, and then I can just go ahead and integrate. Integral of 1 is u, and integral of u squared is u cubed over 3 plus c. And I have to go back to my original variable of integration, which is x. So u I'm replacing with sine of 2x. That's 1/2 sine of 2x minus 1/2 times 1/3 is 1/6 minus 1/6, and then u cubed is sine cubed of 2x plus c. And that's my answer for part 4. Now I have to put all that together. I'll do it like that. So that's where I left off. I left off here, so equals, maybe I'll make a note. So from here I have to go to a star, and here's this star. Okay, 1/8. Integral of 1, and we didn't dx here, so integral of 1 is x, plus integral of cosine is sine, but it's just the basic u substitution, right? Let u be equal to x and go from there. So you'll see that it's just what's going to be extra is that coefficient 1/2 from here. So 2 switches to reciprocal. 1/2. 1/2 sine of 2x. That's 1 and 2, 1 and 2. Minus. Then I have to, since it's minus, we'll be using parentheses, then I have to plug in my result for part 3, which is over here. Remember, part 3 is here. I'm copying it down so you're not gonna see it, but I'll copy it, and putting inside parentheses because of that minus sign. 1/2 x plus 1/8 sine to the sine 4x. Now plus c, I'm just gonna put at the very end. I will combine all constants. Technically, I should have labeled them differently, like c1, c2. Yeah. No, it's gonna bug me, so I'll call those two c1, c1, c2, c2. But then when I'm putting all together, I'm combining all those c's, and I'm just renaming that as c. So plus 1/8 sine 4x. Okay, that's a constant, will be at the very end. And then minus, go back here, minus result from the fourth part, and it's over here. Minus, again, parentheses. 1/2 sine of 2x minus 1/6 sine cubed of 2x plus c. Here it is. Okay, I am clearing all the parentheses and along the way multiplying by 1/8. 1/8x plus 1/16 sine of 2x. That becomes negative, minus 1/16x. That becomes negative. 1/8 times 1/8, 64, minus 1/64 sine 4x. That becomes negative, and coefficient 1/16 minus 1/16 sine of 2x. And the last one is negative times negative is positive. 1 over 8 times 1 over 6 is plus 1 over 48 sine cubed of 2x plus c. And the last part is to combine like terms. So I have x's here, I need the LCD to combine them. So the LCD will be 16, right? So I'm multiplying by 2 on the top and on the bottom here. So it's 2 over 16. 2 over 16 minus 1 over 16, that's 1 over 16x. Now, 1 over 16 sine of 2x and minus 1 over 16 sine of 2x, those two cancel each other out, right? Now those two I took care of, so yeah, that's it. No other like terms, that's just sine of 4x, and that's sine cubed of 2x. So yeah, now I'm just copying that down. 1 over 64 sine of 4x minus 1, no, plus 1 over 48 sine cubed of 2x plus c. Well, and that's it, right? Very easy example. Well, actually it's not that bad, it's just time consuming. So, once again, the main point of this example is that if you have only even powers present, that you have no choice but to use the half angle identities. Where they are, right here, those two. So keep that in mind. Only even powers, right? Only even powers here, or I had a piece, this piece, remember piece number 3 over here? It also had only cosine and raised to the even power. So I used that half angle identity one more time in that case.